Sometimes questions will ask you for the average rate of change compared to the instantaneous rate of change. So we need to go back to what this actually means, which is not something new. It's something that we started calculus with. But as soon as we dive really deep into calculus, we forget about these basic facts. So this is something that would appear in more worded problems applications of derivatives. So when a question asks you for the average rate of change between an interval, so from A to B, what they want is the slope of the line that connects them. So if I have a curve here and I'm looking for the average rate of change from here to here, the way I do it is to draw like a secant line, not a tangent line, a secant line that would go through them, and I'd find the average of this line. So obviously it's not very accurate, but it would give you the average of what's happening, the rate of change. But if I want the rate of change precisely, instantaneous means that it's instant at a precise point, not an interval, then that is precisely the derivative. So go back to the definition of the derivative. Derivatives are gradients, so it's the rate of change. So if I want the gradient at a point, it's going to give me the rate of change at a point. So we need to know the difference between these two, and I'm going to go through a worded problem that uses one and the other, and we can compare them with each other. So pause the video, read the question, understand what's happening, do attempt it on your own before seeing how I'm going to do it as well. So I'm going to start with the first part, and they want the rate of change during the first 18 days. So from the question, and they want the average rate of change, so we have to use that first formula here. Now keep in mind this formula is not new. This is actually the gradient formula where f of b is basically y2, f of a is basically y1, and b could be x2, and a is x1. So this is the formula for the gradient. So we are finding the gradient or the average. This is also how you find the average between 2 points. But more precisely, the derivative gives you at a point. So the part A wants the average rate of change, so we're going to use that. And it wants it for the first 18 days. So you might be wondering, well, what is my interval? Where does it start? Where does it end? First 18 days means you start from day 0 until day 18. So that's our interval. So if I want to use the formula, I'm going to go T18 minus t of 0, it's t because the function is t, over 18 minus 0. So we need to find t18 and t of 0. So t18, you could put this in your calculator if you want to, or we could simplify it using algebra. It's a calculator question, so if I'm just going to use the calculator, it will give me a 0.0297. Now they want the units in the answer. What are the units? Well, notice how the function in the numerator, we're looking at the output, and the output is degrees Celsius. And the denominator is the days, so days. So the unit will end up being degrees per day, or if you want degrees and then day to the power of -1. How do we do it by hand? If you don't want to do it by hand, you can skip through this part. So T18, or let's do T0 first. T of 0, if I substitute in there, is just going to give me 18. T of 18, if I substitute, it's going to give me 18 plus 12, 18, the negative 18 over 3. And if I simplify this, just the power actually, I'm not going to simplify the whole thing. 12, 18, e to the power of -6. And if I plug this all into the formula here, just going to do a line there. Okay, t of 18 is going to be this mess. Again, you don't need to do this by hand, but I do want to show you 18 e to the power of -6 minus t of 0, which is 18, all divided by 18, because it's 18 minus 0. So a lot of the 18s are going to cancel out. So your 18, the 18 here are going to cancel out with each other. So you're left with this. And so these two 18s are going to cancel out as well. And then you are left with 12e to the power of -6. So you can evaluate that, and it's going to give you the 0.0297. Now, part B asks you for the derivative, t prime of n. You need to use the quotient, the product rule for this one. So t prime of n is going to be, I'm going to derive the n first, so that's going to give me 12. The exponent stays the same, and then I'm going to derive the exponent, and the derivative of the exponent is going to be 1 over 3 e to the power of negative n over 3, and that's the derivative. Now, part C wants the exact value of the instantaneous rate of change. So instantaneous, it has to happen on the exact day. This value that we found is the average, the 0.0297. This is instant. We want an instant rate of change. So you have to substitute it in the derivative. So I'm going to substitute in there. I'm going to get a, so if I simplify this, we can simplify this further. The derivative minus 4ne negative n over 3. So I'm going to use that. E negative 18 over 3 minus 4 18e negative 18 over 3. Plug that into the calculator, and it's going to give you about just approximately negative 0.149, again with units, degree, Celsius per day. Okay, it's the same thing for gradients that you're doing per day, because you're taking the rate of change of the temperature with respect to days. Once you do that, then you're taking this unit with respect to days, and that will be the unit. Now, check your answer with the GDC. So if I go to the GDC, I've graphed it already. I could go to second, calculate, and I could go to dy by dx, and I want the rate of change at 18, exact rate of change, and that's going to give me a negative 0.148. So notice how, compare your answers from part A and C, and you're going to see that the rate of change is different. That's because the rate of change at 18, so going back to here, the rate of change, this was the average. The average was 0.02 something. That was the average, but at precisely here, it was negative. Obviously, this is not the graph. But just to show you that it will be different during that time. And what this means is, overall, there's kind of a positive change of 0.02 degrees per day. But at precisely day 18, the temperature is actually decreasing by 0.149 per day. So that's the rate of change. So just to be aware of the wording and just to know which one you're going to use, don't freak out about part A, because this is basically just the gradient formula that you're using and substituting in there.